This is Colin Walker. I'm here with DCTV for DevCentral. I've got one of our engineers here, Kirk Bower. Kirk, why don't you tell us a little bit about what you do and who you are and why you're here?
So I'm a solution architect with F5. So I work with the sales team and customers to help design solutions. And today I'm going to talk about web acceleration. So what I have here on the board, I have a client. Again, it's a web browser since this is a web topic here. I have a big IP, a pair of big IPs, and I have a pool of servers here. So what do you need to do to make the user experience better? Okay? There's kind of two components. One component is there's the client to the big IP going through the internet. Okay? There's latency, there's potential packet loss, there's other issues, there's bandwidth limitations that can make that experience tough. The other side of it is the servers themselves. Okay? If the servers become too overloaded, they're going to respond slower. Corporations don't usually like to have servers running at 5% utilization. They want to get better utilization on these servers, so they have fewer servers than they might need. Unfortunately, this can lead to less user experience, higher latency, higher page load times. So the big IP has a number of features to address this. So let's start on the client side. On this connection here between the client and the big IP, we use compression. Compression basically means fewer packets move over the wire. Okay, real basic. There's a lot of other ways to do compression. The big IP makes it very easy. Just check a checkbox and it turns it on. The other side of it is going to be the server side. The server side, there's a few things we can do. The first issue is every time a client connects to a website, it's going to connect to a VIP on a big IP. Traditionally, let's say with other load balancers possibly, or without a load balancer at all, this client or this connection is going to get connected directly to a server. When another client comes in, let's say a client out here opens the connection, we open yet another connection to another server. And this goes on, and you might have thousands of connections open to your pool of servers or your single server if you don't have a load balancer. The problem is those client connections close and other clients come in and they open up new connections. So there ends up being a lot of connections opening and closing. Depending on your server architecture, this might mean there's going to be a thread spawned, a process created, definitely memory allocation, the TCP handshake. There's a lot of overhead. And in the SSL world, we have to do a handshake for each of those connections possibly, or SSL resume. So what we want to do is we want to minimize the number of connections the servers have to open and close. So we have a feature called One Connect, and that basically means I can reuse these connections that open to the server. When the client closes the connection here, we leave these connections open, a small handful of them. When the next client comes in from another place, we can just simply reuse that connection. Pretty basic stuff, but it can make a big impact depending on your application. So we talked about One Connect on the server side, we talked about compression on the client side. Okay. We also have caching. This is caching of static content. Okay, and we can do that on the big IP, which means we do not have to send every single request to the server. If it's your logo, for example, it's cached in RAM, the big IP can respond. It can respond quicker, cut off this hop to the server, and of course take load off the server. Again, this is pretty basic stuff, but it can make a big difference. We also have one more server offload feature called SSL termination. I'm sure you've heard of that. Obviously, the big IP has compression hardware. It can do the handshake more efficiently, and it can pass this connection back to the server in plain text if you so desire. And one more for you, what we kind of call TCP Express. This kind of works a little bit on both sides. Because the big IP is a full proxy, we can speak as efficiently as possible to each client. We can speak as efficiently as possible to the server, or to each server. And we can do that differently because we have two completely separate TCP stacks. So when the server sends a response, we can collect that from the server very quickly, and then we can spoon feed it to the client as it's ready to receive it. Okay, all of this stuff here is what I would call basic web acceleration. There are other devices out there that will also sell web acceleration, and they do much of this same stuff possibly. At F5, this is kind of our basic features in our LTM load balancer. Okay, any load balancer you buy has this functionality, and you can take advantage of that. We have a product called Web Accelerator. Now this is an add-on module on the big IP, so you can add it on with along with your LTM, or you can buy a standalone device. And this will do acceleration above and beyond this basic web acceleration we talked about here. So there's a few things it does. It does caching as well, except the Web Accelerator can use disk to supplement the RAM cache. So up here, you might be able to cache a few gigs worth of content. Down here, you can cache many gigs worth of content. There is also the ability to cache dynamically generated content that you wouldn't normally be able to cache. I'm not going to get into the details of that. It does require some custom policies, but it's certainly something that you can do on this product. The big thing that I like about it is a feature called IVR. This stands for Intelligent Browser Referencing. Now, what is this? It's actually kind of difficult to understand, so I'm going to try to explain it for you here. Basically, the way it works is you have a web page that the client wants to view. Some people, depending on how much you know about HTTP and how much you've looked into web pages, even if this is a very dynamic site, I mean, this might be something like a news site that changes every single day or every single hour or every single minute. There's still a lot of static content within the page. Let's say your logo up here. There's style sheets, there's CSS files, there's JavaScript files. There are images. Sometimes people will do an image like a corner here, here, and lines. And these are all separate images. And they might have images down here in the bottom of the page, right? So when you add all this up, multiple JavaScript files, multiple style sheets, you have pages today that have anywhere from 50 to, I would say, about 125 objects per page, okay? And again, this page might be dynamic, but these objects change very rarely. They pretty much change when you do a new site, when you do a new skin, when you do a redesign. So the problem is, how long do I want to cache my logo? Okay, logo.jpg. And by cache, I'm not talking about this cache, which this cache is very easy to control. I'm talking about the client cache. The client cache, you don't have any direct access to, right? That client puts it on his disk drive, and it keeps it there for as long as you tell it to. So how long do you say to cache it for, right? You can say cache it for 1 year, because my logo doesn't change very often. But if your logo changed tomorrow, everybody that's been to your site lately is going to have it in their cache for the next year, and they're never going to ask for it again, and they're never going to see your new logo. This is a bigger deal with like a JavaScript file that might have had a bug in it. You fix the bug, everybody has it cached, that bug stays out there until they clear their cache or until it expires. You can't call your customers or even your employees and ask them to clear their cache when there's a problem. So what happens is people tend to set the cache time relatively low. We see cache times of, the most I see is maybe a day. I see 4 hours, I see 5 minutes, I see 0. My understanding of what happens is the first time the CEO calls the web developer at home at night and says, hey, our website's broken, and the developer says, clear your cache. I guess in the next morning, all that cache times come off down to 0 because nobody wants the CEO pissed at their site being broken. So you have these cache times. Let's just say it's 5 minutes. Okay. What that means is I don't have to download all these objects again for the next 5 minutes, or even 4 hours, maybe a more realistic example. And in fact, most of the time it's for the duration of your session, honestly. So for the rest of my session, these objects are okay. Now, of course, every page is going to have new objects that you have to re-download, but eventually you'll have a bunch of stuff in your cache. The problem is you close your browser, and maybe you come back the next day. This internal application, let's say like a collaboration site, you might access that every day or every couple days. Okay, if it's an internet-facing website, your customers might access it. Maybe they access it weekly, maybe monthly, maybe daily. The point is, when they come back the next day or the next time they visit, if these objects have expired, they have to re-download. They have to validate their cache. In fact, the way this works is the browser says, hey, I have a logo, I have logo.jpg in my cache, and it asks the server through the big IP in this case, is that object still valid? The server will respond, yes it is. It's called a 304 content not modified response. That tells the browser it's okay to use that. Okay, and it has to do that for all these objects. Now, It actually sounds pretty reasonable, and it is pretty reasonable in some situations because we're not downloading the objects, right? We're just verifying that they're okay. What kills you is the latency. Okay, so if this client is transcontinental or even international, or a mobile device or an iPad or anything like that over a cellular network, this latency can, we see latencies anywhere from 100 to 250 milliseconds. Okay, that can add up, especially when you think about up here 50 to 100 objects. I'll do some quick simple math. Let's take 100 objects and let's take 100 milliseconds, and let's take a very common browser like IE7, opens up 2 connections at a time to the server. So that basically means you can do 50 pairs of requests times 100 milliseconds equals 5 seconds, okay? If you can read my writing. 5 seconds is how long it takes to display a page that is 100% stored in your cache. And I think if those of you that do have mobile devices, you've probably seen this before, where it takes 5 seconds to display a page that you visited yesterday, right? That's the issue. It's in your cache, but you can't use it until you verify it. So how do you solve this? Well, again, the traditional method was let's put longer cache times. But we can't do that because the content might get stale, it might change, it might be invalid. What IDR does is it gives you all the benefits of a long cache time. In fact, the default, I think, is 6 months. And it gives you none of the downsides. So it gives you, or I should say, all the benefits of a long cache time while providing you all the benefits of a zero cache time. How does it do that? So you take this object here, logo.jpg, and it renames it. So it actually modifies the page, and it puts a tag on it, something like this. And it gives it the browser, and it says, you know what? You can go ahead and cache that for 6 months. This means the browser never has to ask for it again, never has to validate it, never has to check to see if it's up to date. If I visit a site today, and I visit a site tomorrow, all of the objects that are static, looks like the page itself you'll download, but all the static objects are in my cache for 6 months, which means I do not need to do any conditional get. I don't have to get any 3 or 4 responses. I turn 50 round trips into 1 or 2 round trips. And that takes 5 seconds down to a couple hundred milliseconds. Okay, and that's a big deal. Now, what happens if the object changes in the 6-month period, right? The big IP is constantly checking the server. This is very fast over here. It's checking the server to make sure that object hasn't changed. And when it does, it simply changes this identifier to something completely different. When I visit the site tomorrow and I see this object, I look at my cache as a browser and I say, it's not in my cache at all. I do a request, I download it. All the other stuff that stay the same, it's already in my cache. So the point is, I only download objects when they change. I never download objects when they're the same. Again, this is important this is something useful for repeat visitors. First-time visitors on your site will still have to download this stuff the first time, obviously. But when I come back every day or every week, this is going to make a big difference. How do I know how to do these tags? The neat thing is, we simply hash the content on the big IP. There's no database. There's nothing we can lose or mess up. It's simply, what's the object's content? What is that hashed to? Stick it in the URL, rename the object, and that's IVR. Should we talk about one connect? Multi-connect? One more feature called multi-connect. And some modern browsers, in fact, a lot of modern browsers are getting better about this. Traditionally, they open up 2 connections. Some browsers today will open up 4 or 6 connections. Basically, multi-connect is a way to trick browsers that normally open up 2 connections into opening more. The way that works is the browser will actually open up a certain number of connections per host name. So if there is, if you're www.domain.com, I'm going to open up 2 connections to that site. If with multi-connect, what we do is behind the scenes, this will never be visible in the browser's URL bar. Behind the scenes, we rename your includes to be on different domains or different host names. For example, www1, www2.company.com. And that means that the browser will open up 2 connections per domain. So basically, instead of opening up again, the first time visitor, instead of doing 50 round trips at 100 milliseconds to download the first pages, I might be able to do, for 100 objects, I might be able to open up 6 connections, and that means I'm now going to do about 15 round trips times 6. And that means that, again, that latency is reduced in terms of its affecting the user, that the content's downloaded faster, and that makes your website faster. So that is Web Accelerator. This is Big IP, LTM functionality, this is Web Accelerator, and this is the F5 compression story.